Hello everyone, I'm Geoffrey Barret, Luxembourg Director of the Confucius Institute at the University of Luxembourg, and I am very glad to welcome all of you to our today's lecture, The Chinese Space Program, Ambitions, Achievements, and Perspectives. An even more interesting topic that the space sector is quite active in Luxembourg, notably through the Luxembourg Space Agency work and the University of Luxembourg, which offers two space-related master's degrees, an interdisciplinary space master and a master in space communication and media law, and which is part as well of the Université, the European Space University for Earth and Humanity, an alliance of 5 higher education institutions. To give this lecture, we have the honor to welcome Professor Michel Blanc, who is a planetary scientist working at the Institut de Recherche en Astrophysique et Planétologie, a joint laboratory of CNRS, CNES, and the University of Toulouse in France. Among other responsibilities, Professor Blanc is also member of the Air and Space Academy, of the International Academy of Astronautics, and of the Academia Europaea. Mr. Blanc has been for several years the executive director of the International Space Science Institute in Beijing and a visiting professor at the Chinese Academy of Sciences. Before giving him the floor, I just would like to give everyone some practical precisions. In the middle of his lecture, Professor Blanc will take some time to answer a few questions, but the main questions and answer time will be at the end of the lecture. You can of course also write your questions in the dialog box. Professor Blanc, thanks again for being with us today. The floor is yours.
Thank you very much, Professor Barret. It's really for me a great honor to be the guest today of this lecture about the Chinese space program. And I hope I will meet your expectations, knowing that I'm not really what I can say an expert of China. It would be really too ambitious. I am just someone who spent some time in China with Chinese colleagues who have collaborations, who enjoy them. And I am really speaking essentially as a witness, not as a specialist. So this is an important reservation to the value of what I'm going to say. So let me share my screen, and I will start going through this lecture. So the title is about the Chinese space program, its ambitions, its achievements, and perspectives. Well, we know that China really is eagerly encompassing all the fields of space activities. And one of the elements driving that is that the fast economic development of China and the importance of its R&D spending. We know that this is the curves over the years from 1995 of the GDP for some of the major countries. This is the USA, naturally, the largest growing Western country, let's say. These are here. Sorry? Yeah, okay. So this is Japan, South Korea, and Germany. And you see that China has been starting from low after essentially the Cultural Revolution and expanding very quickly. And its investment in R&D spending has gone along with this development. So right now, China is spending about something like 2.2% of its GDP in R&D, which is about the same level as some of the main European countries like France. But with the growth of China's economic activity, it's becoming something which is major in the space field, even compared to the other big countries like the US, naturally, and like Europe. So really, it's a partner which is developing, and as I will see, which offers a lot of perspective in terms of collaboration. So I will go first through the organization, and then we'll talk about the launchers, the Earth observation program, which I think is going to become more and more important with the orientation of China towards let's say, mitigation of global change. Then human space flight, and I will end up with my specialty, which is science and exploration. So in terms of organization, this organization chart is a little bit complicated, I must say, and it's only under my own responsibility. But let's say, take it from right to left. So first, there are two elements in the development of China in space. Access to space, to the right, so development of the capacities for access to space. So these are capacity-driven projects, and they are dominant in the current Chinese program. And science and application-driven activities to the left. So the players which are developing this in China are different on the two sides. So if we take the right side first, the Chinese National Space Agency, which is the space agency of China, is under the Ministry of Industry and Information Technology, and it has, let's say, a key player under it, which is the China Aerospace Corporation. It's a big consortium, actually an industrial consortium, with the different components. China Academy of Launchers Technology, it's the company which develops the launchers. The China Academy of Space Technology, which is basically the industry which develops the platforms and all the capacities for the mission. And to the side of it, there is a special entity which is under both CNSA and the People's Liberation Army, which takes care of the China manned human spaceflight. So that's the China Manned Space Agency. So these ones are developing mission and system studies, small platforms and bigger platforms, and all the manned vehicles for human exploration. Then to the left, you have more under the Ministry of Science and Technology, the players of scientific access to space or scientific use of space. In China, academic research, I should say, has basically three components. The China Academy of Sciences here, which is actually directly under the government of the PRC, so it talks directly with the Prime Minister. It's the equivalent of a ministry, the China Academy of Sciences, so very important. It is managing a series of, let's say, own laboratories, and one of them is particularly important in our field, which is the National Space Science Center. That's where I was a visiting professor over the last few years. The National Space Science Center is basically managing the space program of the Chinese Academy of Sciences, which has its own program. In parallel to it, there is a second research and education system, which is quickly expanding in China. It's the universities. They are developing basically on the let's say, Anglo-Saxon American model. So they are modern universities, and let's say there are more and more resources. And to survive that, we have all the agencies which are thematic, like for instance, weather forecast, meteorology, oceanography, earthquake monitoring, and so on, which are also developing space projects. So that's, let's say, the big picture. And now we are going to go into more detail of the different elements. The first thing to go to space, naturally, is to have a good, let's say, a family of launchers. And for that, China is in a very good position. The Long March family of launchers offers a very broad spectrum of access to space, from launching small platforms to launching humans in space. So it takes really a large spectrum. And right now, in addition to this first category of Long March rockets, there is also a new generation of launch vehicles which offer additional capacity, like Long March 5, Long March 5B, which goes to low Earth orbit. This one goes to geostationary transfer orbit to place, for instance, telecommunication satellites in geostationary orbit, and so on. So this family, for instance, with Long March 5B, has the capacity of launching robotic missions to the moon and to Mars. And that was the case in the last few years, and it will continue like that. So access of robotic missions to the solar system is secured just by this rocket, Long March 5B, which has been now successfully launched several times. So it's a validated rocket. One element which is still lacking in the panoply is a heavy launcher, in the sense of a launcher that can send humans to the moon. We are going there into a new category, so let's say the equivalent of Saturn V, or now the SLS in the US, or some of the rockets of SpaceX company. So they are not yet there, but I think they are eagerly working on developing this heavy launcher, which will be absolutely necessary for sending Chinese people to the moon sometime, I would say, in the next decenny after 2030. So anyway, it's a very good base. The other thing is that China has developed now 4 launch sites. There are 4 launch sites, more or less in the 4 corners of China. And this one, it is the most recent. It's the place from which now lunar and Mars missions are sent. It is on Hainan Island, to the southeast corner of the country, actually the southern tip. It is in a very good location because it is at very low latitudes, and it can launch to the east over the ocean. So just like the Cape in the US. So that means or Kourou, French Guiana. So it's really the launch site for the future, and in particular for going to the different objects of the solar system. So after that, I will go into the Earth observation program. And we will see here that, again, China has a sort of full panoply of Earth observation satellites. It's very important for both science and for, let's say, interest of sovereignty of China. So they have 3 series of satellites dedicated to Earth observation, land observation, ocean observation, and atmospheres. And they are organized in different satellite series and 7 constellations doing regular monitoring, constant monitoring of Earth's atmosphere, surface, and resources, meteorology, and ocean. So I won't go into the details of that, but I just wanted to let you know that this is a very comprehensive panoply. It involves a lot of launches in space. I think actually right now China is the second country in terms of the number of launches per year after the US. So it's a very active program. So
I'm very sorry.
Yes?
Can I ask a quick question? Is it the data open source?
Sorry?
The Earth observation data of this series of satellites, is it open source? Is it for public?
It depends on the program. Some of them, yes. When they are scientific programs, they are open source. When they are application programs that feed national agencies like weather forecasts and so on, I don't know. You have to ask the corresponding agency.
Okay, thank you so much.
So, for instance, there is a national program for meteorological satellite, which is called FEGUM. You see there is a whole series starting from 2010, more or less 1 launch per year. And they are actually covering both geostationary orbit and low Earth orbit to provide the full coverage of the monitoring of Earth's meteorology. Then there is also a very comprehensive program of ocean satellites, naturally monitoring of oceans, their resources, their activity is very important. And also they have one part of this program which is installed on low Earth orbit, and another part which is on geostationary orbit. I wanted to mention that, in fact, in this field, there are both applications and scientific research purposes. Both are sort of in synergy. And I will show just an example which is important for France because it was our first joint satellite with China. It is called CFOSAT, China-France Oceanography Satellite, sorry for the French, observer l'océan depuis l'espace, un nouveau satellite pour mesurer et étudier vent, vagues, leurs interactions et leurs impacts sur les échanges océan-atmosphère. So this one, and you can see all the partners on the French side. There is, CNES, our space agency, CNRS, the main research agency in France, Météo France, our weather forecast entity, IFREMER, research on oceanography, and several industries and so on. So it's organized really as a joint scientific venture. And CFOSAT, in fact, combines a platform which has been developed and designed by China with two instruments, a radar scatterometer for surface waves. So it's a radar which measures essentially the direction and intensity of waves at the surface of the ocean. And a second one called SCAT, which is a radar scatterometer for surface wind measurements. So it measures the wind at the surface from the effect it has on the surface of the ocean. So SWIM is a French instrument, and SCAT is a Chinese instrument, and you can imagine that they look at sort of the two sides of the dynamic coupling of the ocean and the atmosphere, and they are actually providing a cartography of winds and waves at the surface of the ocean. I will just show, just for the pleasure, a result, which is measured by SWIM, global cartography of height, direction, and length of some of the waves at the surface of the ocean. So it's a publication by Daniel Ozer and co-author, Daniel is the leader of the French team on that. And most of the publications are joint with our Chinese partners. It's an open program. And to answer the question that was asked before, at least for this program, all the data is available for scientific use. You just have to ask, naturally, the permission of the principal investigator of the different instruments, but it's accessible and it's done for the purpose of international use. Another example of a Chinese satellite, which I think is very successful, is called the China Seismo-Electromagnetism Satellite. So this one, it's also a platform actually produced by the same operator, DFHsat. It's the provider of small platforms in China, which is under the China Academy of Space Technology. Its main purpose is to monitor the effects of earthquakes and, if possible, the precursors of earthquakes on the upper atmosphere. So it's a very open research field. Actually, we don't even know if there are precursors. So it's something that is really pure research. It is operated by the Center for Earthquake Observation from Space of China Earthquake Administration. Needless to say, monitoring of earthquakes is very important in China. We know that at each major earthquake in China, there are many civilian victims. So trying to forecast, or at least to mitigate the effects of earthquakes is a major societal issue. So this satellite is trying to do that, and it is actually doing it in partnership with other international partners, in particular the Italian Space Agency and the Austria Space Institute. Several of these instruments on this platform are European. I wanted to mention that. I follow more or less the production of this satellite. I must say it is brilliant. There are a lot of new things coming out of this satellite. And this one is just the first of a series which will continue. After CSCS-1, there will be the launch of CSCS-2, I think, sometime this year. And then a series of micro platforms that will continue this monitoring of earthquakes over the world. So I think it's a great example of international cooperation on Earth observation oriented towards the monitoring of natural disasters. So a major societal problem. So now I go to the next part of the space program, which is human spaceflight. Well, we know that China has decided a long time ago to send astronauts in space and to be present, continuously present in space with astronauts. As it was reminded here, the Chinese government decided to implement a three-step strategy. So the first step in the strategy, it was decided in 1992, was to launch a manned spaceship, so the first astronaut, to experiment the presence of humans in space, learn all the effects, learn how to maintain human presence in space. Second step, establish a space laboratory, like a facility where experiments in microgravity in particular could be performed, where new technologies for spaceflight or for presence in space or for observation in space could be tested. So this small space lab has been, I think, quite successful. And based on the feedback and lessons learned from this space lab, which in particular experienced an automated rendezvous and docking between a cargo and the place where the scientific payloads are operated, they are now going for the next step, which is to establish a space station. And the idea, really, the ambition is to establish a permanent space station, which will provide a permanent solution for access to space, to low Earth orbit, and beyond. I mean, a sort of intermediary place for going further to the moon and to the planets. So the plan for this space station is well advanced. First, the achievements: 13 time flights, 6 times manned space flights, 11 astronauts sent into space and were successfully taken back to the surface. And now it's time to go to the space stations. So Space Lab, essentially, it has for objective the transportation of cargo, mid-term stay of astronauts, I mean a few weeks, learn to resupply propellant, for instance, learn the ground-based mission support, carry out experiments, and accumulate experience for constructing the space station. So now the phase of construction of space station, I think, has started. And the idea is to have a station in space by 2022. Maybe I will go through that because it's a little bit detailed, but typically the kind of experiments that are flown on the Space Lab of China are experiments that are oriented towards understanding the behavior of astronauts in space. So a lot of things about human physiology and its reaction to microgravity. And so they learn progressively with that how to maintain astronauts in space for longer and longer times, with the purpose of preparing for inhabiting the future space station on a permanent basis with crew. So the phase 3 space station is actually now under implementation. You have here the basic configuration of the space station. It's a sort of H-shaped system where you have 3 main modules for habitation and experiments, a lot of solar panels for energy. The program for the implementation of the space station, which will be operated with support of a system of vehicles coming to the space station and going back to space to bring astronauts and cargo, will be set up in 2022. So in principle, next year, it should be in the air in its, let's say, smaller configuration. And then during the next 2 years, until 2024, it will reach completion configuration. So it's a China-only program. But I know that the Chinese colleagues would like very much to open it to international collaborations, and in particular at the level of its the scientific experiments it is carrying. So you have here a sort of list of the experiments that the Chinese space station has planned to take on board and to operate. It's in fact very similar to what's developed on the ISS, the International Space Station, led by the US and the Europeans and Japan. There are payloads for the study of space life, so how to live in space, human life, but also biology in general. There are experiments about the behavior of fluids in microgravity and all the problems of combustion in microgravity. It's very important for rocketry interplanetary flight. Behavior of material in space. Fundamental physics. There are a few experiments in fundamental physics in microgravity that can perform only in space. For instance, I just take an example, but experiments about cold atom technologies for high precision clocks, where you use atoms in microgravity to tune your clock to a very, very sharp, let's say, quantic transition. So this kind of technique really works best in space. You gain several orders of magnitude by going to space in terms of atomic clocks and in terms, therefore, of metrology of space and time. And that's something on which the Chinese are also investing. And finally, multi-purpose facilities. So China is trying to develop the management of this science in the space station on the model of the ISS, clearly. And they have contact, or they had contacts with the European Space Agency for exchange of payloads and so on. So that's an ongoing process. So now I'm going to go to the second part of my talk, which is about the same length, about science and exploration. So Mr. Barry, maybe we can have a few questions now, if there are questions. Otherwise, we just go on.
Sure, no problem. So if anyone has a question, we can have, let's say, a little break to ask and answer some question, like 2 or 3, and go on after.
Can you hear me?
Yes.
Yes.
So first of all, thanks very much for the overview on some of the most important programs in China. You did not address, and this is maybe because of time, you did not address navigation and telecommunication. So can you tell us, if possible, in 2 sentences about navigation, how close or how far China is meanwhile in their cooperation with Europe? And in terms of telecommunication, maybe also 1 or 2 sentences, internet over satellites. So what about China and the mega constellations?
Okay, yes, well, I must say, in fact, I did not address that mainly because I don't have much information on that. I mean, I've been working on labs which are not involved in that aspect. On the other side, I am originally a telecom engineer, so I'm very interested in this part. I think China is developing its own network of navigation satellites. Some cooperation with Europe is going on. Another thing I wanted to mention is China is also doing very interesting experiments at the fundamental level about quantum communication, and in particular, they have been flying one particular experiment about demonstrating quantum communication in space. So that's something which is really at the forefront of research in terms of, again, telecommunication science and technology. But otherwise, I could have looked for more information, but really it's not something I've been exposed to.
No problem. Thank you very much.
Yeah, sorry, can I ask a question? I want to know if China is going to contribute to the Artemis program. And because as I heard, they are doing some kind of contract to build a station in the orbit of the moon with the Russian. And also the American and the Europe, Luxembourg, for example, they are also part of the Artemis program, and they are trying to build the gateway in the orbit of the moon. So is the Chinese have like some interest in this field? And also I want to know about the interest of China in the space mining industry. As for the next week, it will be here in Luxembourg, the Space Research Week.
Oh,
This will be
space finding what of the moon or of asteroids or?
well, like both of them, if possible.
Yes.
Yeah, thank you.
Okay, so well, for the Artemis program, as you certainly realize, it's a highly political issue. So I cannot speak either for the Chinese. I'm sure they would be interested to participate, or for the Americans. I don't know if they would be happy to share anything on this program with China, to be honest. So that's something I think which is for the diplomats to manage. Right now, I don't think there is any direct participation of China to Artemis as an international collaboration framework. It's probably forbidden by the rules to which NASA has to obey. But maybe via some European partnerships, and we'll find that more or less everywhere. In fact, China has collaborations with European countries and with ESA, the European Space Agency, and via this link, one can imagine that indirectly China could participate to an American-led program like Artemis. So let's see how things evolve after the pandemic, because it may be that geopolitics changes after the pandemic. We don't know now, but at least what I'm sure of is that China would be certainly happy to participate. Concerning, mining, yes, I think some of the aspects that are driving the interest of China for the moon and for asteroids also are certainly having access to resources, natural resources for future human presence or present bases and so on. So yes, there is research on that in China in several places and several institutions, and a lot of interest.
Okay, thank you.
Maybe one more question before starting again.
Hello, I'm the student of the interdisciplinary space master program, and it's a very interesting presentation. And can I ask, do you know if there are any missions or projects the Chinas will work together with the Luxembourg companies in the futures? If they have any possibles for they cooperate together?
To be honest, I don't know of one in particular, even though I know some programs which involve China and the Netherlands or Switzerland, France, naturally, Italy, Sweden. I'm sure there must be, but maybe it's just my lack of knowledge. And in any case, I'm sure as long as Luxembourg is interested, I'm sure the door is open.
Okay. Yes, thank you.
Sorry for not being able to say more.
Yeah,
I should have looked into that before.
Because I know the Luxembourg Space Agency, they want to attract more companies, the space companies. Also, the Chinese companies come to here in the space industries. So I don't know how the progress with this. And thank you for your presentation.
You are very welcome. Well, I know some Chinese company who would be very interested. That's true.
Okay, then let's continue maybe. And if you have other questions, two options. Either you can write them, as I said before, on the dialog box, or at the end of the conference, we'll take a little time to exchange and share questions and answers. Okay?
Okay. Thank you, Mr. Bai.
Thank you.
Where are you? Where are we with time? Sorry.
So now it's around, you still have like 30 minutes, something like that. Yeah,
Okay.
30 minutes.
Okay, good. So now I will go into what's more my field of activity, I mean science and exploration. And I will start, in fact, by saying that there are two components in the Chinese program oriented towards space and space science. One which is really science in space, science of studying the universe and the solar system objects, and also fundamental physics. So this program is managed by the Chinese Academy of Sciences. It's not a surprise, but and it has been developed essentially, in fact, sort of in parallel or maybe even in reaction towards the fact that the big part of the Chinese space program at the beginning was essentially capacity development oriented. So it was the role of the Chinese Academy of Sciences really to take the lead for developing science in space. And that's what they have done under the leadership of Professor Wu Ji, who was my first host in China, and who really designed a tool which they call the Strategic Priority Program on Space Science, which is managed by NSSC, the National Space Science Center, whose current Director General is Professor Wang Qi here, and the Deputy Director, Professor Dong Xiaolong. All three sent me most of the information I'm going to present here. Then the second part of science exploration is the exploration program itself. And as we will see, it is more capacity-oriented than science-oriented, but naturally science and technology in the end will talk to each other to produce nice results. So I have no question about that. So let's go through this program. I won't go into the details, but it's really a program which is similar to the ESA science program, the science program of the European Space Agency. It covers fundamental physics, physics of the universe and astronomy, the study of the solar system, and the study of what we call the space environment, which is basically the ionosphere and magnetosphere of the Earth. So what they do, they have 5-year plans, and for each 5-year plan, they have a selection process like we have in Europe, actually on the same model, where they select missions, scientific missions for study. There is a competition, and once the missions are ripe for flying, they are implemented. So here, during this first 5-year plan to 2011 to 2016, there was already 4 missions launched, and very successful ones. One on the study of dark matter in the universe, one which was an experiment to study microgravity and fluids in microgravity in space. So it was a component of the space lab I showed before. Then a satellite for X-ray astronomy called XHMC. Actually, I had the pleasure and honor to be at the launch of this satellite in Xinjiang province in 2017. And something about quantum experiments at Space Quest. So some experiments of the laws of quantum mechanics in space. To support this, they have a department which does intensive study of future space science missions, and another one which studies the payloads, so prepares really the instruments to be flown. So you see, it's really something which is built more or less on the model of the European Space Agency, the kind of thing you find at STEC, for instance. And there is no surprise for that, because in fact, Professor Wu Ji spent a significant amount of time at STEC working with European scientists and engineers. And I think he liked the model and tried to implement it in China. So now for the next 5 years, 2017 to 2022, so we are in it now, there are 4 missions. Einstein probe, it's a very interesting astronomy mission which will study the emission of X-rays and gamma rays by so let's say, stars falling into the black holes of galaxies, I summarized. An advanced solar observatory that will monitor the activity of the sun. JCAM, it's essentially something that will be a precursor to the detection of gravitational waves in space. And the SMILE mission, which is a mission dedicated to the study of the Earth's magnetosphere, on which I will develop a little bit more just after that, because it is a joint mission with ESA. And then there are several other missions which are under study, and you see that they address very different types of subjects, black holes, and how to detect waves, how to detect gravitational waves in space, sample return from a comet or asteroid, something to study the dark ages of the universe, so the radio emissions of the early universe, just before the appearance of the first stars, the sort of, roaring of the young universe before the creation of the first stars, and some additional missions. So all these are really very exciting missions that are, I would say, first rank on the world scale. SMILE is a mission that will study the Earth's magnetosphere from space. It's a joint mission between the European Space Agency and the Chinese Academy of Sciences, not CNSA. It is CAS, which is the partner of ESA in that case. It's a very original design where a satellite will be placed at a high altitude over the poles of our planet to monitor the aurora and X-ray emissions of the magnetosphere to try and understand all the dynamics of the aurora, of the boundary of the magnetosphere, and therefore how, let's say, the solar wind and solar activity shapes our Earth environment and is more or less harmful to Earth human activities. So this mission is under development. I think it will be launched in 1 or 2 years from now. Really totally integrated Europe, China mission. Let's say that also it was selected on the basis of an open call for ideas and on the basis of, the best merits. So with that, I will now move to the exploration program and finish my presentation with that. In a way, it's sort of the bigger, or maybe the most visible part of the Chinese space program, and that's why it plays a very important role in its development. So the Chinese Planetary Exploration Program is a very ambitious, really capacity-driven program. Again, science is not the driver, but science benefits from it clearly. So there are two components. To the left, what China calls CLEP, the China Lunar Exploration Program. So go to the moon and by steps be more and more present in the study of the moon. And in parallel, deep space exploration, which will start with Mars, and actually there is a mission orbiting Mars right now, then the asteroids, then Jupiter, then the interstellar medium. So a stepped development where the plan is to go farther and farther into the solar system. So let's go first to the Chinese Lunar Exploration Program. The logics of the development is shown here. It started about 2007, orbiting, so the first phase, then landing, and sample return. We are actually already on the first and second step have been accomplished, and we are in the third step, which is the sample return. So Chang'e 1 was flown in 2007. It was an orbiter of the moon. Again, the Chang'e 2, it was the transition. Chang'e 3 and 4 were the two missions that really landed on the moon and operated the small rover. And now with Chang'e 5, which has been successfully launched in December of last year, and Chang'e 6, which is in preparation, by the way, with partnership from my lab, we are in the phase where China is returning samples to the Earth for scientific analysis. So let's go through that. So the first I wanted to show you first a short video, which is interesting because it is a summary of the whole program. And at the same time, it was done in 2017. So they talk about some elements of the program in the future, even though now they have been accomplished. And so we will see actually this accomplishment. So let's go for just this short video. So 2007, the first flight, Chang'e 1. Orbiter, and impact on the moon. And the first images of the moon by China. Chang'e 2, we do a full coverage and cartography of the moon to prepare the next steps and select the future launch sites. And after that, it actually visited an asteroid, Tutatis. So you have here the first 7-meter resolution full map of the moon provided by China. Then the start of the landed phase with Chang'e 3, which landed on the near side successfully and deployed the first little rover called U2-1, the jade rabbit in Chinese, U2. So this rover was only partly successful. It worked for just a few hundred meters and then failed. But as we will see, Chang'e 4, its successor, was fully successful. At the same time, they prepared and tested technology for the return of samples with a mission which did not land on the moon, but went around the moon and sent back a capsule towards the Earth to just test the technology for returning samples to the Earth. So again, this was fully successful, and it explains to a large part the success of Chang'e 5. So they show here now the scenario of Chang'e 5. Just have a look, it's absolutely breathtaking. Landing, then takeoff with the samples, automated rendezvous in lunar orbit, transfer of the samples between the return vehicle and the capsule that returns to Earth, and finally sending the capsule into the Earth's atmosphere to make a hypersonic re-entry and go back to the surface. So what's interesting is that was a cartoon, but the real mission has been done now, and it's been totally successful. So Chang'e 4 was also successfully implemented, and as I will show later, they deployed a relay satellite on the far side of the moon because the landing was on the far side for the first time. So they could not relay directly the data to Earth. They have to go through this relay satellite. And many telecom stations of the world contributed to gathering the data back. So these are some of the instruments of Chang'e 4. And in fact, some of them are European, like this one, radio astronomy. This is my colleague Bob Wimmer from Sweden, sorry, from Germany. Okay, so, well, it's a sort of a commercial about the Chinese lunar exploration program. And what is interesting is that all the missions that have been planned and shown in this movie have actually been operated successfully. So Chang'e 4 in particular, which was launched in the end of 2018, launched on the far side of the moon for the first time. It was the first far side landing in January 2019. It's a totally successful mission. It has deployed this little rover, U2, which has done a traverse, as we are going to show. I would like to mention the specific interest of this mission. Here, you have a global map of the moon where you see all the places where there have been landings, starting naturally with the Apollo landers and the next missions. And what is important is that what is interesting if you want to make a general plan for, let's say, exploring the moon, you need to go to different types of, let's say, geophysical or geological provinces. You need to go to the Maria, you need to go to the high mountains, you need to go to the deep craters, and so on. And it is important to go both to the near side and to the far side, because as you can see just by eye inspection, near side and far side have very different morphologies. The far side is much older, but it has a very important and interesting feature, which is this big impact crater. It is actually the largest impact craters on the moon, and it is on the far side. And some of the places here are very deep. You have here the sort of barometry of the moon. And Chang'e 4 landed actually on one of the lowest altitude sites of the whole moon. Why is it interesting? Well, because there we believe that the impact has been so strong that it has pierced the crust, and probably we have access to material from the mantle of the moon. So from the point of view of geochemistry, it's a very important place to go. And that's why this going to the far side was not a premiere just because it was the far side, but in fact because it was going to a very interesting place from the point of view of its scientific interest. So U2 was successful. It did a traverse of the moon, and along this traverse, it did a lot of studies about, let's say, the morphology of the lunar surface and regolith and so on. So it was really a very successful experiment. And now, as we know, Chang'e 5, which is the first sample return mission, has also been fully successful, and it has returned several kilos of lunar sample from the near side for the time being, which are currently under distribution to the laboratories. I don't know exactly where it is, but we are in the process of going towards the scientific analysis of the samples. So China is now preparing for the second sample return mission called Chang'e 6. And let me say that there is scientific payload which is developed by our lab with a partner of the Chinese Academy of Sciences, and that will participate to this next mission. So you have here, I like very much these pictures. This is a picture of the recovery of the capsule that took the samples from the moon to Earth last December. So it's in the desert of Inner Mongolia. And you have the team here, which has recovered the capsule when only part of the team naturally. And I can say this colleague is very happy because behind him, what you have is really a scientific treasure, several kilos, of lunar samples returned from the moon for the first time since basically the Apollo and the lunar hod eras. So something very important and exciting. So what is the continuation of the Chinese lunar exploration program? So as I mentioned, first the second sample return, it should be maybe around 2026, something like that. I think it's under planning. Then the next step, polar landing. We know that around the poles of the moon, there are a lot of mineral resources and water resources, and that's very important to monitor, in particular in the perspective of establishing permanent lunar bases someday. So China will go there, actually not only China, but the US also, Artemis, and all the programs interested in the moon are going towards the poles because that's where most of the resources are located. And the long-term plan, if I may say, around 2030 for China is to develop not yet a human presence on the moon, but what they call the International Lunar Research Station. So it's a sort of network of robotic lunar stations that will do science together on the moon at different places. So that's the perspective for the lunar program. And now let's go further into the solar system to finish this talk. So the next step is Mars, and actually Mars, it's underway already. Tianyan-1, which is the first mission to Mars of China, has been launched in July of last year. Successfully transferred to Mars orbit, and now with all its components, it is in orbit around Mars, preparing for the landing. So the landing, you will see that it's a rather complex mission. So this is the orbiter, which is right now orbiting Mars with naturally all the solar panels deployed. It will release a descent capsule that will go into the Martian atmosphere. And within this descent capsule, once the back cover and the base will be detached, there will be a landing platform, so a scientific base for scientific investigation, and a small Mars rover. So the small Mars rover, you have it here, and I cannot resist the pleasure of showing you actually a very small copy of this rover, which was offered to me by some of my Chinese friends. So it's a very nice present that I wanted to share with you. Naturally, it's not at scale. You can imagine it's much bigger. And well, we wish our Chinese colleagues the best possible luck in this landing. I mean, landing on Mars is always very challenging, Until now, only the United States have been able to do it successfully. So let's hope for the best for the Chinese mission. But Mars is not the final destination. After the first Mars exploration, if it is successful, and I think it's a key element, there is a plan for a Mars sample and return. So returning sample from Mars, we know it's very complex. NASA is doing it in 3 steps, which have started now. China is planning to do it in only 1 step, which I think is very ambitious. Then there will be the continuation of robotic exploration of deep space. And the next step, which is already in the planning, is an asteroid exploration mission. I will show the mission profile later. Then a mission to Jupiter, and maybe flying by Uranus. And finally, there will be a mission going into the boundaries of the solar system, what we call the heliopause, and into the interstellar medium. So let me show you some of the plans. So the asteroid exploration mission, again, it's a very ambitious mission. So this is the scenario. Start from Earth, deep space maneuver. It will go in orbit around a near Earth asteroid. A small lander will be deployed to the surface, while the main orbiter will do remote sensing of the asteroid. Then the small lander will go back via an in-orbit rendezvous to the main craft. The main craft will go back to Earth here, and it will release a capsule that will re-enter Earth while it will fly by Earth. But it will continue its flight, and after this Earth flyby, it will do a Mars flyby and go to a main belt comet. So there will be then an orbital observation of a main belt comet, and that will be phase 2 of the mission. So you see, very ambitious mission. In the same mission, sample return, 1 asteroid, 1 comet. After that, Jupiter system exploration. So that's something which is just on the breadboard, let's say, okay, no, not yet even a decision, but the idea is really to study the Jupiter system, study the Galilean moons, in particular Callisto, which is the farthest moon in the system, and which is the one which is keeping the traces of the formation of the Jupiter system. So the mission will be oriented, likely, towards understanding the origins and workings of the Jupiter system. And finally, the last project I wanted to mention is called Interstellar Express. You see here that there is a sort of a political slogan, but it's more than that. I mean, it's a scientific mission. The idea is for China to reach 100 astronomical units away from the sun in 2049. So, 100 astronomical units for the 100th anniversary of the People's Republic of China. But beyond that, the idea is really, you see here in this logarithmic representation of the distances in the solar system, going beyond all the main planets, I mean the terrestrial planets where we are here, yes, terrestrial planets, giant planets, ice giants, the boundaries of the solar system, which we call the heliosphere, and going into the interstellar medium towards the nearby stars. So that's really the plan of this very ambitious mission. It has several scientific objectives of major interest, exploring the property of the interstellar medium for the first time, the medium which is separating us from the nearby stars, determining the structures and dynamics of the heliosphere. The heliosphere is the bubble, the magnetic bubble within which all the planets of the solar system reside. We don't know exactly what shape it has. Is it a sphere? Is it an ellipse? Is it a parabola? So we need to look into it in different directions. Understand the evolution of the solar wind, so the output of the sun, which strikes all planets. And finally, studying some of the primitive bodies of the solar system. So the plan for this mission is underway. There actually has been now a scientific team appointed, and they are working on the scenario of this mission. And the idea would be maybe to have 2 probes launched in opposite directions in the solar system. One towards the nose of the heliosphere, and another one towards the tail of the heliosphere to look at the asymmetry of the heliosphere in 2 directions. The way to do it is use Jupiter for gravity assist to be propelled farther into the solar system,
because actually
and to use electrical propulsion. So that's the plan, and I suppose it's one of the missions which are really scientifically very appealing for, let's say, the midterm future. So I would like to make now some tentative conclusions before opening the discussion. So the Chinese space program, as you have seen, addresses more or less all areas of space activities, and based on an adequate infrastructure and rocketry for access to space. So it has a sound base. It is mainly technology driven. I mean, until now, the examples of the exploration program and of the Earth observation program are good examples of that. They develop more the technologies and the sensors first. There is a significant portfolio of international cooperative programs in oceanography with France, Earth observation with Italy, for instance, and others, space weather directly with the European Space Agency, astrophysics. Again, there is another Sino-French mission to study gamma rays in the universe, which is in preparation. And it's ongoing. I think our Chinese partners are really eager to develop, expand international collaboration, as far as I can see from talking with them. So, well, what next after the pandemic? Many things may change, including the global balance of the economy and the international relationships and so on. But we don't know if there will be new priorities. The degree of success of the Mars mission, I think, will be important to determine how fast China will go into the outer solar system, because it's a key point there to test this capacity of going to Mars. In any case, in my view, China represents a potential partner for Europe in space, an important one, with its volume of activities and the interest of its missions. And I think they are eager for cooperation. And, well, I am a scientist, so I will end up by saying that scientific cooperation is the ideal field to test and possibly expand this cooperation, offering win-win opportunities and the access to an expanding space program. So thank you very much for your attention, interest, and I'll be more than happy to answer questions.
Thank you very much, Professor Blanc. Thank you very much for this very interesting lecture and for sharing your knowledge first. It allowed us to learn and know more about what it's done actually, yes, in China in terms of space program and equipment, tools used for this lunar and even further exploration. So thank you. Now,
Thank you
if you have, yes, if you have any questions, do not hesitate. We have some times now. So yes, either you can write them or we can exchange orally, no problem. You just need to activate your microphone and that's it.
I don't see the question, so maybe I will stop sharing.
Yep.
I have a quick question, if possible. I asked a lot of questions, but it was really interesting. That's why. Thank you. Well, my question is about the private sector in China. Is there companies working on the space industry right now, and are they really working in something good, or what is happening in the space in the private sector in general?
I don't know personally some really private companies. The ones I know are really under the China Academy of Space Technology, which is an industry, but a state-owned industry. And the state-controlled industry, for instance, I have collaborations with the DFH-SAT company, which is the company which developed the small platforms, that the one of CFO-SAT, and CSCS. They are pushed, and I mean really towards going to the private sector. I mean, making money from selling spacecraft and so on. And I think there are other partners expanding in China in the private sector. So I think it's a field which is going to expand very quickly with new private partners coming.
Okay, thank you so much.
Any other questions?
Yes, hello. One question on my side. Are the Chinese completely independent in terms of technology and let's say components? For instance, the Americans, I know that they maybe still use Russian engines to launch their satellites, or they use some components, for instance, from Russia. So are the Chinese completely independent from A to Z, or they still need to cooperate with other countries?
Well, I cannot say I have intimate insight on that. I will give just my impression. My impression is that China really wants to reach technology independence. That's strategic for them. For sure, there have been in the past some important cooperation with Russia. There is no doubt about that. I don't have the impression it's critical now. Because in fact, if you look at the current developments of the space programs in Russia and China, they are sort of let's say at the best on the same level. I don't think there is a technology dependence right now of China on Russia, except maybe on things like provision of nuclear material for radioisotope thermal generation of energy in space or things like that, you know. But for most sectors, launchers, for instance, are totally independent and so on. And they want to be.
And do you think that this ambitious Chinese program will stimulate the development of fundamental sciences in China, and also will stimulate the technological advancement even ahead of the United States?
Well, I
That's
think
one of the goals, of course.
My impression is that, as I said at the beginning, the Chinese program started by as a capacity-driven program on developing the capacity of going to space. And in a way, it's the same phenomenon that occurs in the West. I mean, in the US and in Europe at the beginning of the space age. Let's say the Apollo program was not developed for science; it was developed for securing the presence of humans, and in particular Americans, in space. And I think we have the same logic in China. First, it develops as a way to have access to space with an interest which are not particularly scientific, but in the wake of this development, science is making a lot of profit, let's say. So this profit may be indirect by a development of technologies for space, by a use of space for science, or it may be direct. An example of this direct scientific benefits is the program I showed, which is what we call the Strategic Priority Program for Space Science, developed by the Chinese Academy of Sciences. And in this program, very clearly, everything is science-driven. And it is the scientists, I mean, the astronomers, the geoscientists, and so on, the explorers of the solar system, who define the mission from scientific objective towards mission design and implementation. So I think we just have the same logics of space development. First capacities, then technologies, then science. And in the end, I am convinced as a scientist that science benefits a lot, even if it has not been a driver at the beginning.
Yes, because we know that, for instance, the aerospace industry developed new technologies that were used in the daily life afterwards, right? So that
Absolutely.
also drove the American superiority in the technological field in the 20th century. So maybe the same logic will be applied for China. It will not only adopt but also invent completely new technological products.
Yes. Well, you know, as I showed at the beginning, R&D investment of China is really becoming very important in volume, and I would be surprised that it does not produce original science and original technology, and that would be really surprising. I think it will, and it does already.
Thank you very much for the interesting presentation. It was really very appealing. Thanks.
Thank you.
Thank you. Do we have another question? We still have a little time, so if you want to ask, do not hesitate. No more question then? Let's finish this lecture then, if you agree. Yeah? Okay.
Thank you.
I just wanted to add just a few words about our Confucius Institute activities. Do not hesitate to follow them. You can find them on our website, Facebook, LinkedIn, YouTube, as well as on WeChat. If you have any question, do not hesitate to contact us as well by email or telephone. For information, we're based in Belleval, in the Maison du Savoir of the University of Luxembourg. So I wish everyone a great day. thank you for your participation. And Professor Blanc, thank you again for your time. It was really, really interesting. Thank you very much.
Thank you very much for your invitation. It was a great pleasure and honor. And see you soon, I hope.
See you soon.
Goodbye. Have a great
Bye-bye.
weekend.
Bye.